Hello everyone, my name is Chetana Sabapan. Today I'm going to explain uh, how designing digital keycode for digits. So uh, the problem of this assignment, which is assign the four digit numbers are the last four digits of student numbers. So my last four digit numbers are 0, 0, 5, and 1. So before I can go to design anything, so let's talk about preprocessor unit. Preprocessor unit uh, it is explain all of the circuit working. So preprocessor unit has three blocks, which So the preprocessor unit has three blocks. So the three blocks, the first block is called left block. The second one is middle block, and third one is right block. So about the left block, we have to have an input in here, which are the digit numbers that I press is 0, 0, 5, 1. But there's only three numbers that I'm going to press. Is uh, which is I have to press switch 0, switch 5, and switch 1. And the rest of them, uh, I call it false, but but I I will call them I will call them as I enter. The rest of the number has 2, 3, 4, 6, 7, 8, and 9. So this circuit is I gonna call enter. The enter is press any numbers besides of 0, 5, 1. So we have input in here, but as you can see in this in the enter uh, which have a NOR gate because we don't want them to we don't want them to register in this circuit. So the left block, so we have input uh, in inside the left block is combination circuit, and the next block and the next step is middle block. So the middle block is flip flop. But I can call another name of flip flop is but this block is called memory. So the middle block is flip-flop because I have to the middle block is flip-flop because it's a memory uh because it's gonna because they're gonna remember that the digit that I press. So when when the flip-flop working and it will gonna be loop go to the left block again because uh when I press the first digit, so it's it's gonna back to left block for waiting another digit that I going to press. And always the middle block should have a clock signal because flip-flop always always have it, but if without them it cannot working. And the last one is right block. After that, after we press the 4 digit, the right block will work. So it's combination circuit again. Uh, sorry, it's just LED. It's an LED to show the digit that I press. So how many LED have? So I assign that there are 4 LED which have set 1, set 2, set 3, and set 4. Set 1 is show the first digit that, that I press. The set 2 is show the second one. Set 3 is show the third one. And set 4 is show the fourth one, and all of them is working. All of them show that means we we press the 4 digits we complete to press the 4 digits to unlock the door. So so um so the preprocessor unit is done. So let's go to the next step is designing a state diagram. So if you can see here, the passcode is 0051, and yeah, I assign some alphabet is X is press 0, Y is press 5, and enter press 1. So the first of working of this circuit, which is press 0, which is state A. When I don't do anything to it, it still loop is x is 0 because I don't press anything, any numbers or anything. Uh, the next step, when I press 0 is that means x is 1. The next step is step B, which is wait for release release 0 because this stage I, I still pressed and do not release yet, so this state is loop when x is 1. But if I mess up or anything, such as I press 0 and I accidentally press any numbers which is false, so it's go back to state A again. And next state is state C. When oh god, the next state is state C, which is when I release the 0, which is x is 0. Let's go to the next state is state C. State C is wait for the press 0. State C is press 0 again. But if I mess up again, so it's going to state A again if I press anything wrong. And state is still for loop is if I don't do anything to him is which is enter is 0. So the next state when I press 0 again, which is x is 1, is go to the next state is state D. State D is like the state B is wait for release 0. And yeah, if I still press 0 is still in this stage, which is x is still 1. And if I mess up again, if I mess up by press any digit, so it's go to state A again. So the next one I release the 0, which is x is 0. It's go to state E. And then state E is press 5. The state E is still state E when I don't do anything to him, which is enter is 0. Enter is mean press any numbers, which is mean false. And then if I mess up again, go to state A again. And then when I press 5, which is well, my pen is not working. Okay, here we go. So when I press 5, which means y is 1, That means it go to the next stage is stage F, is which is the state is wait for release 5. If I still press, it's still in stage F. And then if I mess up again, if I press anything wrong again, it's go to A. The next one is after the release switch 5, which is Y is 0, it's go to a next state, which is state G. The state G is press 1. The state will not go anywhere if I don't do anything to him, which is enter is 0. And if I press the wrong digit again, it's go to A, like another state. Okay, when I press 1, which is set is 1. That means it's go to the next state is stage H. The stage H, which is wait for release 1. And then if I still press, it's still in this current stage, which is stat is still 1. And then if I mess up again, it's go to state A again. And then if after I release 1, which is the stat is 0, it is go to next state is state I. Stage I is unlock, which is I press all the digits and the circuit is complete. And then unlock, it had a LED show too. So in this state, it's unlocked. When I don't do anything to him, enter is still 0. But if I press enter, which is false, enter is press any numbers. That make stage is go to reset again and go to state A again. So this is how a state diagram look like. And yeah, and then next one is state table and assignment. So how did I do that? State table is a state the state write the present stage, write all the action of state diagram. So this table is called a present stage. And this is the next stage. And the last one is output. So the next stage, how the next stage working is from I press the switch, as you can see here. I assign that X is press 0, X bar is not press 0, Y is press 5, Y bar is not press 5, Z is press 1, Z bar is not press 1. Enter is mean press any numbers, uh, which I can call another name is false, but I forgot to write another one is enter bar, which is not pressing any numbers. So how I can write the state table? Hello, this okay. So the stage is ready for to write. So the present stage, which is the order of stage is A B C D E F G H I. Oh, I forgot another one right here. And then the first one is stage A. How many action? As you can see instead here, x is still 0. X is still 0 when sorry, the state A is still A when I not press anything, is which is x is 0. And when I press X, which is go to state B. And the next one is state B is from here. If I'm not press 0, it's go to state C. And if I still press X, it's still in state B. And output of this two is still 0. And then the next stage is state C. The state C, when I okay, gonna here, when I press 0, which is x is 1, which is right here, which I press X, is go to the next stage. But if I don't press anything, it just press anything, it's go to A. But I assign that if I don't press anything, it's enter bar, which is still in state C. And the next stage is wait release 0. So the x is still working in this diagram when x is 1. And then when I release 0, which means x is 0, is go to state E. Oh, I forgot to tell you something. The LED is the first LED show is at state C, because the first digit had just registered. Okay, the next one in state E, the enter is 0. That means still in this stage. And yeah, if I press 5, which is y is 1, it's go to the next stage. Oops, oops, wrong one. Press y is here, and go to f in here. And yeah, state f, which is wait for release 5. The state is still working when y is 1. And if I'm not press 5, which is y bar, which is go to the next stage, which is stage G. And yeah, the stage E is uh never mind. So the next stage is stage G. The stage G is still stage G when I'm not press any numbers, which is enter is 0. And and if I press 1, which is set, is number 1. If go to the next stage is stage H. And then if I still press H, is in this stage S is still for is still loop. Is if I still press set, which is press 1, the state is still working. And if I release set, which mean wait release 1, so it's go to the next state is state I. And then the last stage is state I. So if I in this stage, if enter if enter is 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 0, which mean don't press any numbers. So it's go to enter bar, and there if I press any numbers, which is enter, it's go A. So the rest of the table in here is A. It's all A because it's 0. It's all 0. Enter is all A is 0. So the next table is output. So I will explain again. So the output is which is a LED show. So the state A, I assign that when I finish press any numbers, is LED it will show. So the output is show when I don't press any numbers after I press the number which is have state C, which is here, state E, state G, and state I. So in this highlight, the output is 1 because it's completely because it's completely pressed and register in this register the digital key code already, and the rest of them is 0. And yeah, here we go. It's done. State table is done. And the state, what is state assignment? State assignment is, which means is a is a which is change when the alphabet in here to the numbers. So how so assignment, instead assignment just change. It's like it's like a state table, but state assignment is change everything in here to the numbers. So I can write it again. Present table, present stage. Next stage, output. So the state A oh, I forgot I again. Okay. Okay. So here we go. State assignment, which is a change all of the alphabet to numbers. So the stage A is 0, 0, 0. Stage B is 0, 0, 0, 1. Stage C is 0, 0, 1, 0. State D is 0, 0, 1, 1. State E is 0, 1, 0, 0. State G, state F is 0, 1, 0, 1. State G is 0, 1, 1, 0. State H is 0, 1, 1, 1. And the last one is I is 1, 0, 0, and 0. So state assignment is pretty similar to a state table, but just change all of the alphabet in here into the numbers like this. So let let me write the thing down. This is going to take for a while. So the output is like a state table. So I can write it here. Yeah, it's done. The state assignment is done, and the next step is which is which is designing logic. So before I can do that, uh, in middle block is which is flip flop. So I gonna use throw flip flop. Oh, sorry. In this flip flop, in this block, I use only D flip flop because each of D flip flop only have one input. And clock signal. So why I use 4D flip flop? Because the state is half 9 have 9 stage. So if I use 3 flip-flop is which is a thing to multiply 3 times, which means they only it's only use the the 8 states. So but in this design I use 9 states, so this is cannot be worked. So and it's not correct. So uh the right thing is use for flip-flop because because when you use for flip-flop is 2 multiply with 2 4 times, which have 16 stage. Is this is enough for making a circuit? And yeah, the middle block is done. The D flip-flop has for it is. So the D flip-flop is will be like this and have clock and use about for oops. I think I messed up again, so I can gonna draw. So each the D flip-flop is it has some equation, some combination circuit in here. There have Q0, Q1, Q2, and Q3. So we got a middle block. We got a middle block already. So alright, the next one is equation. What is equation? Equation is designing the left block, which is a combination circuit. So how I do that? From stage assignment. From stage assignment from here. You all see is just all numbers, but it's very useful when I design combination circuit. So Q0, how do I know? Is Q0, Q1, Q2, and Q3 like this? It's from the this. You can see in the left one is Q3 and and in left to right is Q3, Q2, Q1, and Q0. So all I have to do is excuse me. So the next one is making a left block. The left block, the first one is designing Q0. So you have to find the equation is have one is have Q0 is 1 is right here. Find all of them that Q0 is 1, and then I can making an equation. So from the state assignment Q0, I will write the easier thing that from state assignment if one has A, B, AX, BX. So excuse me. When you write an equation, you have to choose the midterm form. So midterm form, which is the equation, all of them just go and then each of and from any stage, and then all of them just are going to R. So this one right here. So I'm gonna write the equation. Q0 is AX, BX, CX, DX, EY, FY, GZ, and HZ. And all of them just go R like this. So I from the alphabet to the numbers is 0, 0. You can see the numbers. I don't write the numbers in the equation because it's wrong. We have to write in this form is Q3, Q2, Q1, and Q0. So A is 0 is all 0, which means Q3, Q2, Q1, and then bar B is Q. Oh, I forgot something. Q2, Q1, Q0, and bar, and X. B is 0, 0, 1, 0, which means Q3, Q2, Q1, and Q0. Bar is mean 0. Is 0, 0, 1, 0. X. C is Q3, Q2, Q1, Q0. Is oh, I apologize about B because it's wrong. So the B is 0, 0, 1. So it can write Q3, Q2, Q1, Q0, and then it's 0 in Q2, Q2, Q1, and 0 is the 1. I'm sorry for that. D is Q3, Q2, Q1, Q0, and it's 0 at Q3, Q2, and then X, and then EY, and then E is Q3, Q2, Q1, Q0. 0 is in Q3 and Q1, Q0. G is 0, 1, 0, 1 is Q3, Q2, Q1. 0 in Q3, Q1. And GZ is Q3, Q2, Q1, Q0. And how is 0 at only 3 and Q0. H is Q3, Q2, Q1, Q0, and then it's 0 at only Q3. Yeah, Q0 is done. And then back to state assignment. Choose Q1, which is Q1 is 1. It's right here, right here, right here, yeah, right here, right here. Okay, back to this write equation of Q1 that have B x bar C x D x F y that G z is z C enter and G enter. And then it's transformed to that to logic equation again. So I gonna write writing equation is going to take a while. And the rest of them is enter bar, is C enter and G enter. So C is Q3, Q2, Q1, Q0. They have bar at this. Okay, I complete Q1 and uh, the next one is Q2. So how I can write Q2? So in this table, you have to choose choose the state had Q2 as 1, which is have this 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 this. Okay, we choose. I have a little mistake in here. So I think, and the last one in here. And all I have to do is write an equation when of Q2. So I cannot write things down. It's got Fy that G set. Right. So So convert the alphabet into logic equation is be like D is so we have complete Q2 already. So the last one is Q3, which is Q3 in here is 1. Find I'm gonna find it have only two equations, so it's gonna easy. So the last one is Q3. Q3 had headset and I and enter and convert to logic equation again is Q3, Q2, Q1, Q0 set and Q3, Q2, Q1, Q. Okay, all of them just finished right now. Equation is finished right now. That means the left box is complete and I have to go to my circuit. So here's the circuit. Here's my circuit about. It's kind of long, but yeah, here's the circuit of it. So let's go to text vector. This is the text vector that I assigned. So if I run this simulation, it's going to be like this. So I will explain how this is work. So I can So I will explain the 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 test vector table. Uh, from this simulation, then the will see uh, in clock 0, excuse me, in clock 1, in clock 0 1 is still 0. Okay, from this clock 0 is 0 1. From clock 0 1 is still 0, which means I I don't press anything, and this state is clock 3, is clock 2. When I press 1, the first LD show is working. So but it's gonna delay. It's gonna delay. It had a delay to LD to show. Uh, and the next sorry, in clock 6 and 7 and 0, because it's released from pressing 0, and then clock 8 I press 0 again, so it's gonna delay. It's gonna delay for a while, and the LED in the LED 2 just shown. And then the next stage is when I press 5. When I press 5 at the clock in the clock 13, when I press and release, uh, the status excuse me, clock 13 to 15 is press 5 in here and release, and 16 to 20 is released from pressing 5, and then uh, and then it, and then the third LED shown, and then the last one is press 1 in here in clock 21 to 24. It show the last LED, and finally in clock 37 and 28 there's enter. That mean can press any numbers instead of this, like 2 3 4 5 2 3 4 6 7 8 9. But you can also press 0 1 5 to reset to state A again, which is the all of circuit is reset. So that's all of it. Thank you for listening.